describe gas behavior. And if we remember from our ideal gas law, we've got volume, pressure, temperature, and the number of moles. Boyle's gas law has to do with changes in the volume and the pressure while the number of moles and temperature are constant. So Boyle's gas law is P1 V1 is equal to P2 V2. And what that means is, and we have here for Boyle's law, we have an inverse law, so that as our pressure increases, our volume decreases. Okay? Now, let's take a look at this problem. It says that divers get the bends if they come up from a dive too fast because nitrogen gas is dissolved in their blood. It expands, forming bubbles in their blood. Oxygen is bound to hemoglobin and is not always dissolved in the blood. If a diver has 0.50 liters of gas in his blood under a pressure of 250 atmospheres, then rises instantaneously to a depth where his blood has a pressure of 50 atmospheres, what will be the volume of gas in his blood? So we want to know, what is the volume of gas? We want to know the volume. All right, let's look at what we've been given. We've got P1, which is at 250 atmospheres. That's a really high pressure. And the volume of gas that we have at that pressure is 0.050 liters. And at this new pressure, get the pen to write. At this new pressure, we've got 50 atmospheres. So what has happened to our pressure? Our pressure went down, so that means that for our answer, the volume should go up because we have an inverse relationship. Inverse. So we are actually looking for V2. Hey, V2, that's what we need to know. All right, well, we've got our Boyle's law over here. We've got P1, V1 is equal to P2, V2, and we need to solve for V2. To do so, we've got to divide both sides by P2. Notice that on the right-hand side, our P2s cancel out. So we've got V2. The pen doesn't want to write 2's. It's going to be equal to P1 times V1 all over P2. Now all we have to do is plug in our values. Notice that both of our pressures are in atmospheres, so we don't have to convert anything. So we've got 250 atmospheres times 0.050 liters, all divided by 50 atmospheres. Let's stop and take a moment and see how many significant figures we have before we do our answer. For our first question, for our first pressure, we've got two significant figures in P1. We've got two significant figures in V1. And we've got three significant figures in P2. So our answer should have how many? Absolutely correct. It should have two sig figs. So that's going to be 0.25 liters. Now, does that make sense? It makes sense, yes, because our V1 is 0.050 liters, and our V2 is 0.25 liters. So it makes sense because we have an inverse relationship.